Hi, welcome to Mix and Jam, a channel about game development experimentation. Today's project is based on Red Dead Redemption. On both games in the series, there's a Deadeye mechanic that allows you to slow down time and target multiple enemies at once. My goal for this project is to try and build a similar mechanic using Unity. These are the steps I needed to follow to recreate the Deadeye. Build the aiming behavior with target detection, create the sequence of shots for all of the targets, and recreate the visual effects. For this project, I'm using the same third-person camera control from this tutorial by Filmstorm. I downloaded some rifle animations in Mixamo and implemented them using Unity's animator. I also got this model of a rifle by Uncle Ben from Sketchfab and attached it to my player. I've started building my script for the aiming behavior, in which I modify the values of the camera's field of view and the tracked object's offset to zoom in and out. For detecting targets, I've used a raycast that origins from the center of the camera and points forward by using physics.raycast. When finding the objects in the raycast, I store them in a list of transforms so I can reference them later. To build the animation sequence, I downloaded DoTween to my project. I was able to create a timeline of events using DoTween sequence, where I could easily append tweens or callbacks. So on my sequence, I go through all of the targets on that list of transforms and append a DoLookAt tween to the character so it can look to all the targets one after the other. I added an animation trigger and interval to the sequence so that the shot and reload animation could start and finish before the next lookat. To make time slow down while the Deadeye is happening, I simply modify the time.timescale property. In order to make the camera movement not be affected by the timescale, I enabled the ignore timescale property on the Cinemachine brain. I started adding enemies to the scene. To make the enemy hit look more realistic, I add a ragdoll behavior to it by simply using Unity's ragdoll wizard, in which you can drag all of the respective joints of the character to the window and hit apply. So in my code, I went back to the Deadeye sequence and called a function that activated the enemy ragdoll when shot. And to add a sense of impact, I used add force to the enemy's rigid body on the specific body part that was targeted. For some polish, I started working on some particles like the muzzle flash and the shot smoke. I implemented the same UI element as the game to indicate which body part of the enemy is locked in the sequence. I added some post-processing like bloom, depth of field, and motion blur. But the most important post-processing effects in this case are the color filter, chromatic aberration, and a vignette. Those three effects only show up when a Deadeye is happening, so I activate them on and off depending on what's happening. I also implemented a screen shake on the shot sequence by using Cinemachine's impulse source. After a bit of adjustments, this is how it turned out. As always, the link for the project's repository is on the description below. There has been some great response to all of the videos and I'm extremely happy.
Okay, so that channel always has some really good stuff. Highly recommend just kind of going through the mix and jam videos, you know, maybe for some inspiration and learning about approaches to various things in Unity. But we'll probably be seeing more of these videos at the start of class here and there. So let's come back here and pick up on some more VR stuff. Okay. Not from the beginning. Okay, so going to be kind of picking a headset to kind of go with here, and that's namely the Oculus Rift, of which we have like, I don't know, like a dozen or so of these kind of on the shelf in the lab, you know, when you find yourself back there. So it should be relatively easy for you guys to access. When you're developing things for it, though, you're going to want to make sure that you allow it to run stuff from outside sources. So when you install Oculus and you get this thing up, this is kind of like the portal that comes with it. You'll have to go in your settings and make sure that this is checked on. Otherwise, you might not be able to launch your stuff from Unity, or unless Unity automatically does that. But in any case, this is part of the setup. And one of the things I've been digging into a little bit, because somewhat recently I saw that many things have changed inside of the VR space for Unity. And I saw that there were some new systems coming in that seemed to be the preferred way of doing things. And Unity, actually, at the beginning of the year, they had a blog post where they kind of detailed what they're planning to do going forward. So a lot of the old stuff is kind of going away, and it's going to become much more modular and decoupled than kind of these big monolithic systems. And if we look at this diagram here on the right, you can kind of get a better feel for how it's laid out. You'll see that there's this thing called the Mixed and Augmented Reality Studio, MARS. I have not been able to check this out just yet, but it seems like an interesting way to possibly author mixed reality content. And you know, then you have your apps that are kind of sitting on top. But the thing that Unity is going to provide is big ones are this XR interaction toolkit and AR foundation. AR is really specifically just for, you know, augmented reality headsets, you know, where you can see the real world through it. But XR interactions, they've made it so it kind of generalizes for both. And that's part of their plan going forward, is that augmented reality and virtual reality, like there's just so much crossover between those two that it makes sense in a lot of places to kind of combine them. So when it comes to interactions, you know, you should be able to do those in either one. So this gives us one place where we can kind of just code it, and that will be transferable from one system to the other. The other big piece, besides consolidating augmented reality and virtual reality, is the fact that we have all these different devices and their own SDKs to use them, right? There's like AR Core, which is Android's augmented reality thing. There's AR Kit, which is Apple's, right? You've got Oculus, you've got Windows mixed reality. We have some of those in the lab as well. Magic Leap, which is an augmented reality device. And of course, there's support for other people to add stuff there as well. I think I mentioned last time that Steam VR, or for the Steam-based headsets, they are going to have their own hook into here. So hopefully the idea is that you'll be able to code your apps with respect to something that will just work across the board. And we're not really quite there yet, but I see it kind of coming together. If you wanted to future-proof your stuff, then this is probably the, you know, future-proof as best as you can in the software world. But if you were planning to work on this for an extended period of time, this would be the way to go. So the new system, it looks a little bit different. If you bring up your project settings, then Normally before you would have done everything inside of the player and you check boxes and it would look similar to this. But now your your plugins are kind of handled separately outside of the player. They're in XR plugin management, and you can check the ones that you intend to use. Not terribly different from before, really. I guess the thing that's in common to both the old system and the new one is this this drop down right here. This, I can use this now. There we go. There's a spotlight. The idea of like which stereo rendering mode you want in here, and I'll briefly touch on what this really means. So I think that comes up next, right? So if you can remember from WebGL, right, you'd submit a call like draw triangles or draw whatever it was, right? That whole thing would kind of get done all at once, and you would see it kind of appearing on the screen. If you could imagine doing draw calls for each thing that's popping up on the screen right now. You can see that we have to do it for each eye, and if just kind of the naive perhaps way of doing it is just to, hey, all right, we'll render everything for the first eye, then I'll render everything for the second eye. But this leaves a lot of performance on the table, which, as we saw yesterday, is just critically important for this sort of thing. So the next step up would be to, instead of going from multi-pass, you would have a single pass, right? You would have this way to draw the same object, but you draw it to both eyes. And I think Unity actually has this where you can do it in a single draw call. But that's, at first glance might not seem like that's saving us much. You're still doing all the same work, but it actually kind of is, right? Because moving things around in memory is a really expensive thing to do. And if I'm rendering one of those little asteroids in the left eye and then I render it again in the right eye, well, it's already in memory sitting there for me to deal with. So there is less memory juggling to slow things down, and things are really just ready to be drawn again really quickly without having to prepare, get everything set up the same way. It's also pretty expensive to like say, hey, I'm going to render with this shader, and this shader has this properties, and then I'm going to render with another shader. The more of those types of state changes you make, where you have to change your shaders around, like it can have a real performance impact. And if you're just rendering the same thing twice, well, you have things that are sitting in memory in a nice way, and you don't have to change your render state. You can just keep it in a render. So this is preferable if you can do it. But there's a caveat to this, right? Like a single pass is it's implemented in a different way than what you might think, right? It's actually internally, if we look at this, it would be rendering not once to each eye. It's rendering to one giant screen that they split in half. So then they can kind of resample that back down to the appropriate size. But when you do this, right, that's kind of a non-standard way to render. We normally render treating it as if we're getting the whole screen, but now it's like you're splitting it in half for each side. So that's okay if you're using all the normal Unity shaders, right? They're built to support that sort of thing. The problem comes if you're going to write your own shaders, or if you use a package off the asset store that has some custom shaders, which is fairly common. There's just some tweaks that would have to be done to make it compatible. So something to be aware of if you're trying to get that squeeze that extra bit of juice out of this, and you want single pass and it's not working. But if you want to be lazy about it, like multi-pass will get you there, and if you have strong enough hardware, maybe it doesn't really even matter. But you can pretty much expect things to work as best as it can when you use the slower multi-pass version. So we're going to get into this and start playing with a few things in here. Let me see. I might go down this route, or maybe we'll let me think. Which one do we want to show first? I can come in here and try to reproduce this right here. All right, so let's set up a new scene, or rather, let's duplicate this. And what do we got in here? So that's already sitting in there. Okay. I'm going to just make this from scratch. So I have an environment. Okay, so little lit prototype interior. And we want to start using the new system. So let's see what we got to do here. I have my project settings already set up here. And if we look in player, here's where you would have set this up before. You can see this is grayed out because, let's see. I mean, I'm not supposed to check that, but there was some more setup in here that I think I already did. I guess the first thing to do to make sure that this is ready is to note that there's a couple different places where you bring packages into Unity, right? You're used to the asset store, and that's been the traditional way where everything kind of went through. But now there's kind of two worlds where things live in right now. It's, it's kind of a transition sort of thing for Unity. I think a lot of stuff is moving more and more toward this idea of their package manager and making the asset store, as you know, it just be a web page. But if I bring up this package manager, not right there, right here, you can see that there's a big giant list of stuff, and that's everything that there is. If I look at just the things that are in my project, it's a much shorter list. And what Unity does is that they have this distinction between things that come in packages versus things that are just in your project as assets, right? And when you make stuff, you're always putting it underneath the assets folders, but there is this magic packages folder down here that you don't edit, you don't create any of this stuff. The only thing that should be down here is stuff that was imported directly through this package manager. So to use the new system, you have to get some of the new packages, and like was mentioned in that Unity blog post, right? This is XR interaction system. I guess let me go back to this picture, right? XR interaction toolkit, they called it right there. So here's the subsystems. You need to make sure that this is checked in. And actually, really the version that's in there by default is very limited. So if you really want to be on the cutting edge, and when it comes to this particular topic, you probably do, you'll need to come up here and go under advanced and click show preview packages, because normally it will show you an older version of things. And let me stop this, get Steam out of here. I was trying to download a game to showcase some things, but I don't think I got it in time. So let's see. Here's everything that's in my project, and I've already said advanced, but and it's up to date. If I disable this, I didn't disable. Oh, I did. Show preview. All right. So you want to make sure that you have XR plugin management in there, and then XR interaction toolkit. It should say preview before it, so that you have access to all the like kind of core features that we'll be wanting to play with right here. So good, that's in there. Interaction subsystems, and when you add those packages, they'll appear down here underneath this folder, which basically just means that things should work now. So let's get this scene ready to be used. First up, we have to kind of create this structure for our camera, because now our camera isn't really just free floating in the world based on your mouse position or anything like that. Now it has to actually be anchored in the real world. So we're going to have to make some things relative to that. So to start off with, I'll make a new object. I'm going to call this my VR rig. And inside of this, I'll make another object, which I'll say as the floor. And then from here, I will actually create a camera. right there, which will be my VR camera. I'll keep it tagged to main camera in case it cares. And this will be kind of the basic structure of what we're working with here. So now we just have to know what are the right components to get in here to make this work. And let's see, for camera, let's look for XR. You know what? Let's go start from here. We have XR rig right there. I'll add, there's a component called XR rig, and base object is VR rig. Let's tell it where the floor is supposed to be at. So that's the floor. The camera game object is that. Tracking origin, I want it to be on the floor. And I wonder if that'll work already. You can see I have this green box letting me know kind of where it's at, which is kind of sunk into the floor. Maybe I'll bring this back a little bit. All right, so now if I'm lucky and I hit play, my headset's difficult to use this with my headphones at the same time. All right, so that's not good because we didn't have everything that we needed yet. This kind of sets things up, but it's not actually tracking anything in space yet. So if I come back to my camera, you need to add something that does the tracking. So there's a tracked pose driver, and yeah, generic device. Yeah, I don't think there's anything special to use here, but now let's see if I hit play. And okay, there we go. So now it's tracking my head. I can move my head around, and I see it directly in the editor. That's pretty nice. If I come up here, you can see I could switch so I look through the right eye or the left eye, or I could look through both eyes. And even with the occlusion mesh on there, right? So there's actually part of this that is masked out. So, but it doesn't really matter for here. Now we got the headset working. It's good. So let's see what else we want to do. Probably get our hands inside of here. All right, so that's our camera. Let's add some hands in here. So let's say that I'm going to create empty. Say this is right hand. Duplicate that. Left hand. And if we want to have these be tracked and be somewhere, then we'll need to have a tracked pose driver on these guys as well. Or no, actually, maybe it wasn't. It was XR controller. So XR controller node, right hand. Okay. So let's add XR controller here. Left hand. And at this point, we probably will see it being tracked, but I don't think won't be able to see much. So let's see here. There's this. Let's come to the scene view. You can see that I can move the headset around. It's moving. Let me pick up one of these controllers. This one. Okay, here we go. Here's the left hand. So you can see that I can move the left hand. You see that moving around there too. But it's just an empty game object, so that's not really cutting it for us just yet. All right, so let's give these guys something to use. Did I do this for both of these? Right hand, left hand. Seems like it's good. All right, so I'll create a cube. Maybe do something like 0.02, 0.02. I don't know, 0.5. Maybe that's not big enough. Maybe 0.05. All right. Let's bring one of these down underneath the left hand. And now let's see what happens. All right, so, okay, this is cool. Like now I got a hand that's pretty much a block. Not super exciting, but you know, you can see it. You can also see a lot of near plane clipping right there, which isn't great. So let's take care of that. Go to the camera. The near plane is currently set at 0.3 meters, so 0.01 will hug it in nice and tight. And now, let's see here. Now that we can get in there and look at our space, maybe we can try just some basic interactions. So let's see here. I want to try to make a little table here where I'll have a little sphere that I can bat around. So let's create 3D objects, Pro Builder Cube. No. Bring this up. This is my play space. So I put it right there. All right, so let's do a little bit of quick editing here. Pull this out. Maybe like that. This one out like that. And now I want to extrude up the sides. So what is extrude? So Control E. Oh, let's take a guess. I think that did it. Yeah, okay. So that gives us a side there. Let's give me that. Let's extrude this. That'll work. Extrude. Same thing, and then maybe we'll pull out the back a little bit. That'll work. Here's my very, very chic couch here. Good. So there's something I can put stuff on. Let's do something simple like put a sphere on here. So 3D object sphere. Come on up, sphere. That's a pretty big sphere. Maybe I'll scale that down. Oops. Scale. Not that. That'll work. Okay. So that's sitting there, but I want this to be physically interactable. So let's add a rigid body. That should be good. If we want our hands to actually collide with it nicely, Unity doesn't necessarily like things to be moving in the physics system unless they have a rigid body. So we can do that for both of these guys. Actually, let me select both cubes. Rigid body. And I'm going to say they're kinematic because I'm controlling this. And let's see here. All right, so there's my hand. Come in here, back a little bit maybe. So I can't really get to it without hitting my desk in the real world. So let's tweak the VR rig a little bit. So VR rig. That's fine. Let's get it a little bit closer here. Try that. Right. So, okay. Yeah, that works. Got our hands, we can start playing with some things. You can get a feel for some interactions. I think we'll basically go more into we'll continue developing this much more next week. But for now, I kind of just want to step aside and show you just some different different kind of methods and modalities of interacting and moving around in VR through some other projects here. So I'm going to get out of this. Let's go to the Unity Hub. Show you. I'll show you the virtual reality toolkit, which was up till recently probably one of the better ways to make your VR code work across any headset. But its future seems a little questionable. However, they do have a lot of nice examples that we can look at to get a better feel for these things. But let's see. All right. Examples. Controller events, straight pointer. Start there. Okay, so I'm gonna have to take my headset off of this so that I can actually see in VR what I'm doing. But I'll check back in here shortly in case you guys have questions or comments. Great. So touch the touch the screen. So you can see some dots like selection here. So, all right, there's an extension of my hands. I get green to let me know things are okay. Red, it's unbalanced sky. Not really a lot to see in this scene. It's kind of like a very minimal first approach to pointing in VR. Can you guys hear me okay while I'm doing this? Maybe type something in the chat. Let me know yes or no.
Your sound is very faint.
Very faint. Okay, let me see if I can. I can. Okay, so I'm trying to Frankenstein this up a little bit. I think I can make it work. Okay, there we go. Now I have a headset on top of a headset. All right, let's get out of this scene. Go to the Bezier pointer. And Bezier pointer, this has the same issue, which is where's the camera rig? OVR. Oculus, OVR camera rig. Eye level. All right. There we go. Okay. Switch my hands here. So now we got something else, right? It seems like computer graphics, it's all about dot products and Bezier curves. At least they show up like all the time. And here's yet another use of these things. Right? So instead of a straight line pointer, we can actually use a Bezier curve. So you can imagine kind of the control points getting tweaked to create this curve, right? Because you don't really want your players necessarily to be able to teleport infinitely far away, right? You want them to move, a reasonable distance based on where they're at normally. So let's see. To do this, nothing special here. VRTK has a couple different options, right? You could sporadically do this dot thing. You could have just the line. That's fine. Or you could customize this, which pretty much any like real game would have something much nicer looking. I will, if not today, show you some examples of what $100 million can produce in VR, and that's through Half-Life Alyx, which is extremely impressive, and kind of show you how they pretty much refine all the stuff I'm going to be showing you right now. So, yeah, there's where I'm going. It's twisting around. You got a little animation. Not bad. Let's go to the next example. Teleporting. And let's make sure the OBR isn't stupid. VR, lower level. Okay, so press the touchpad to activate the pointer. All right, so now we're actually using this for something other than just kind of indicating what I want to select, right? This is actually going to be used to teleport my location. So you can see that basically we have a quick screen fade out, and then you appear in the new location. Locomotion VR is, look, there's my hands over there, but so VRTK can have some kinky, weird stuff some kinks to work around, and like your hands not following you, but they do provide a lot of good stuff out of the box. Anyhow, with locomotion, right, you normally have a limited physical space. You don't have the benefit of something like what the Void has with a big warehouse where they can tailor their experience to match the real physical world. Normally you have some self-contained space, and you have to make do with that the best you can. And there are a lot of different approaches that you can have to that, but nothing that's really a home run there. One of the problems with VR that we'll come back to, or you'll find yourself coming back to, is the idea of comfort and simulator sickness. And so the way you move is one of the biggest contributing factors to cause something like that. And generally, if you're trying to move larger distances, teleport still seems to be one of the most comfortable thing for most people to do, right? You're not actually moving. When you move yourself in the real world, you actually move in here, but if you want to move somewhere far away, right, that you don't have this disconnect between your body seeing like you should be moving and not feeling like you're moving. So teleport is always something you probably want to have in your pocket for a lot of scenarios, unless you have it really self-contained. Let's see if this has anything interesting. Gray objects in the scene are not a valid teleport, right? So you can say what is okay to teleport to or not. This object has a mesh collider. All right. Destination points. So another way to do it is you could say, hey, you're not allowed to freely move anywhere. There's just these certain places on here that you're allowed to go to. Or you might want to tell your players, hey, if you're going to go to this specific point of interest, I want to make sure you're facing a particular direction. So those arrows indicate that when I teleport there, I'm going to be facing back this way. And there I am. And that can be a little bit jarring. Let's see. It's destination. Teleport. Oh, makes me fly all the way up here. Cool. So that's just kind of the blink method of teleport. I believe they had a way for you to toggle a different version. No? Maybe it's in a different one. Oh wait, there it is. All right. So something that's a little bit more aggressive rather than just kind of fading in or fading out and fading back into the new spot would be to kind of still have that fade in, but also have this interpolation that kind of makes you fly toward the target. So you get this sense of direction that you're moving in. And this is pretty fast, but you can always tweak the speed of how fast this sort of thing is. So. Okay. Let's check out the next one. Get off the screen. Teleporting interactable objects. Save. VR. it's already set the floor. Good. All right. So, okay, this is just a whole bunch of ways that you can explore with the interactions that are already built to a toolkit like VRTK, and what I'm sure what Unity have is kind of getting toward as well. Interactable objects. Okay, so warp with the line pointer. Let's see, there's my hands. Flying saucer can only be grabbed with the left controller. Well, that is true. So I got that. Pick stuff up. Objects only react to a near touch and the touch of the controller. Okay, so you can see that it just reacts to it. It's not, you can't actually pick it up. This one can be grabbed and attached at an origin point. And, I can't. I'm having tracking problems here because this thing is like almost under my desk. Let me see here. Get this chair out of the way. All right, so let's look at that. I pick it up. You see it pretty much snaps to a specific spot, right? I didn't really pick it up on the edge where I wanted to it. And sometimes that's desirable, sometimes it's not. If you want to actually pick something up right where you touch it, you know, you can also do something like that too. Let's over here. And you can also have this guy, which if you hold a button down, that thing will just move. And this guy's you can only pick it up with the right. Let's go explore, see if there's anything interesting over here. Oh, can I like build a guy? What is this? This could be attached or what the deal is. Oh, hey, it looked like it was gonna attach. All right. Snap drop zones are predefined areas that interactable objects can be dropped into. Well, it sounds like that's a thing, but I can't actually drop it in there. All right, so I'm getting really tangled here. Let's see, let's come over here. Snap drop zones, toggle on and off. Let's go. All right, so I'm having some space issues here. I'm getting tangled up in my cords and gliding into things. But let's see if there's something I can get to here. Grab mechanics, attach objects to the controllers using a variety of techniques. It's kind of cool. Cube can use a fixed joint, right? There's different ways you can pick these up. Like before, I think it was just reparenting something, right? If you imagine all those matrices, it's just saying, okay, now the cube is a child of your hand and it's going to follow. But another way to do it would be to attach a physics joint, some sort of connection to it. So it's almost like a link in a chain, right? So which can be a little bit different. It should interact with physics just fine. See, so you get that for free. Whereas if it was just firmly attached to your hand, you wouldn't get those nice physics interactions. This cube uses a spring joint to attach. Oh, that's fun. So, hey, physics, chill out. All right. We lost the orange cube, everyone. This cube becomes a child. This cube tracks the physics. Will automatically drop if the controller goes too far away from the object. So I guess this is kind of cool, right? So if for some reason, you're got knocked into something, your hand went through it, you just lose the object. It's kind of good to have things play nice with the physics if you want it to feel real and not have your objects doing kind of impossible things that are not helpful to your simulation. Hold button to grab equals false. This is a toggle grab. All right, well, you don't have to hold the button down. You just click it and it's grabbed. This cube follows the controller. Moving the transform. What? That's interesting. Interactable objects can automatically orient it on grab. So let's see here. We want to make sure they grab in the right place. Hold button to use true. Here's a gun. I don't think that's really how I wanted to grab it. This guy. Hold button to use equals false. Oh. That's cool. Automatically oriented on grab. This doesn't seem like it's automatically orienting. This one? Maybe? If I grab this like this. Yeah, so this one reorients, right? It's like, even if I grab it sideways, it comes up right. So that can be pretty useful. And there's lots of little subtle details like this when it comes to interacting with objects in VR. And if you can take advantage of the fact that everyone knows how things behave in the real world and make it like that way inside the simulation, it'll feel just very intuitive and natural. This cube will uniformly scale when grabbed with the second controller. Oh, sweet. Okay. This cube will scale in the direction. Okay. Or can be grabbed with the secondary controller. So that seems a little broken. This gun can be grabbed with the secondary controller. All right. Well, I think you guys get the idea. Let's get out of this one. See how tangled up I am in here. So interactable objects, movement types. Yeah, there's a couple things I want to point out here. Let's see here. OER. Okay, different movement types. We've already seen teleports. Climbing, slingshot, position rewind, comfort tunnel. All right, well, it might take some time to go through all those, so we can pick this back up on Monday. Let me get out of VR. So I hope that starts to give you guys kind of a feel for the the VR landscape. Think a little bit more about the ways you can interact with it and what the implications are of your choices. So I'll stick around if you guys have any questions.